All right. Well, I hope everybody is tuning in. This is a very sporadic way of learning a little bit about machine learning. And I'm gonna do a little bit of a review of the bike sharing case study. This is a total. I won't dive in exactly what we're doing. I just want you to see how are the many ways of creating a model and how to do some techniques so that you can predict the best value or the best business recommendations for your uh, whatever model you're working on. But this is a really good example and case study, and I wanted to share with you all. So I hope this thing is on. I hope this is already going. It looks like we're going, but I don't see. Let me know if you're seeing it on the live website. I'm gonna check my other computer just to make sure that it's running and we are not losing time over here. And thank you guys for joining, whoever has signed up to become part of my channel. This is a channel that I use to just provide information that makes sense to me, and I like to actually to share with other people that follow me. So again, this is the machine learning case study. We are looking at the bike sharing case study. For those people that are just joining us, I'm gonna go ahead and dive in. So as you can see, this is the bike sharing case study. At this point, you have already run your Jupyter Studio, which is what you're looking at. I'm actually going to increase the size of the screen. I just noticed that it's a little bit hard to read, but this is what it looks like. And I'm going to expand. As you can see, I ran the Jupyter. Again, if you don't know how to run Jupyter or how to install it, there are many ways that you can start with it. And I mean, you can just search online, say like how to install Jupyter on Mac per se. So I'm using Mac, and so there it is. You just follow those things. It tells you how to install it, how to run it, and that way you don't have to install it any other way. I used to install it using Anaconda, which is another tool that we use, or that it is advised to use. But let me see. It has a lot of other stuff that I don't really need, so that's why I decided to go away with it. And so basically this gives you a bunch of other tools that you can utilize and to do all your data science and other stuff. I use the free tier, and so yeah, again, you just come in here, look at the installation tutorials and everything, or the examples, the guides, where you're going to install in Mac OS or any other platform. It's very easy to install and very easy to get going, very easy to just get going. It probably takes you about 5 minutes. It actually takes longer to install it than to run it. So those two are the items that you can install. Jupyter straight through, and then just follow all of that. I already have the case study. I already have my CSV file, and so with that, we're going to dive into the problem statement. So again, this is the bike sharing case study, and the problem statement says, the bike sharing system are a new generation of traditional bike rentals where the whole process for membership, rentals, and return has become automatic. Through these systems, the user can easily rent a bike from a particular position at return and return to other position. Currently, there are about 500 bike sharing programs around the world, which are composed of over 500,000 bicycles. Today, there exists a great interest in these systems due to the important role in the traffic, environmental, and health issues. I know we all seen them. I don't think I ever rented one. Actually, I did rent one in Miami a long time ago, and yeah, if nobody thinks about those logistics, and it's like who is gonna rent it from this location, and then where is this person gonna return it? So all of that, it's pretty cool. Like all that, how that data is collected and all the information kind of like has some value. It's like whether you rent it from across the street or across the corner, all those things. You look at the back end and you say like, oh my gosh, this person rented it here, but the other the return was over on this side. So seeing all those trajectories and everything where the bikes are moving towards, you can actually position the bike rentals at a better place and to get the best value out of them. And so here the objective is to travel along in a new bike sharing company and it wants to expand its customers count and provide better services at a reasonable cost. They have conducted several surveys and collected the data about weather, weekends, holidays, etc. from the past 2 years. Recently hired data scientists at Travel Along, that's the name of the company. We have been asked to analyze the patterns and in the data and figure out the key areas which can help organize to grow and manage the customer demands. Further, you need to use this information to predict the count of bikes shared so that the company can take prior decisions for search hours. What are the different factors which affect the target variable? What business recommendations can we give based on the analysis? How can we different ensemble techniques, bagging, boosting, and stacking to build model to predict count of bikes rented? So this is what the main objective of this case study is, like using different ensemble techniques. Ensemble techniques are like bagging, boosting, and stacking, just to name 3 of them, but there are other. So the data description, so they give us the whole data, they describe the data for us. So the bike sharing rental process highly correlated to the environmental and seasonal settings. For instance, weather conditions, precipitation, the day of the week, season, the hour of the day, etc. can affect the rental behavior. And so with this is the data set that they provided and the description of, sometimes you would get data that is not, you don't know what it means, so you need to find out exactly what it is. They might be saying like, like this one, DTE day is actually the date. Season, they describe the season as 1 for spring, 2 for summer, 3 for fall, and 4 for winter. So yeah, it looks like it already has had some cleanup. So we might see I'm gonna expand this. It might be that there has been some cleanup in the data set, so that is a plus. And the reason I'm saying that is I haven't looked at the data set, but I can see that number 1, number 2, number 3, number 4 are tied into the name rather than having a string as a value. So whenever you get a data set and it has strings, you have to convert them into a number, because that's the only way that we can compare or we can analyze the data or the data set when we're conducting any model or any analysis via machine learning. And so I'm not gonna go through all those. You just kind of glance at them, and then we can just continue on. I pre-installed everything, because it takes a long time to install if you don't have a good GPU, or if you are running a really heavy or really big data set, it will take longer. Or if you're doing some models with extra capacity that your machine doesn't have. So I don't want to load it, and I preloaded everything. So yeah, this case study was missing the GBoost, XGBoost installation. So I went ahead and added the Python installation, and I just entered that, ran it, and that is already here. And then we imported other libraries like Panda, NumPy, Seaborn, Matplotlib, which is they're all like plotting graphs plotters. 3 modeling and ensemble from sklearns. Here's the one that we just installed, which is the XG regressor for regression testing, and then sklearn metrics and the model selection. So now, then after that, we import our CSV file that we saw in the previous Jupyter screen that I showed you guys. And so then we run ahead just to see the first 5 entries from the data. And as you can see, you can already tell that they did a lot of cleanup, like the date, instead of having some other value that is like non-readable by the data set or the data models. It was all clean and everything, so we can see that it is all numbers, all integers. And again, we run this and we check to see what the import is like. So we have this many index values, so it goes for a while. So all the entries for this data set, and none of them are null, so none of them have any missing values. So all of them have some sort of value, and the data type is some sort of number, with this one being an object. So we're going to see what they do with this object. It needs to be translated into an integer or some sort. And then we have integers, floats, which are treated as integers. And now we're going to see, we can see that there are a total of 17 columns and 17,379 rows. The data set, all columns and data types are either integers or floats, except for one column, date, which is the object type that I mentioned over here. The number of non-null values in each column is equal to the number of the total rows in the data set. Non-null value, we can further confirm this is NA method. So they use the NA method to, I don't know what that means, so let's look it up. I never used the is NA in the data set. And where would that be coming from? Let me do a little search over here on the side. Don't mind me just now, and is NA in Python. Okay, so the isNA method checks whether the object of a data frame or a series contains missing or null values, NA or NaN, and returns a new object with the same shape as the original but with Boolean values. Okay, so basically checks the data set if there are any any missing values, and then it sums it and presents them. But there are none. So there are no missing values in the data. That's just what that is. It's like you have to prepare the data before you even get to start showing what's in it. So you want to clean it up and do a bunch of So here, summary continuous columns. It just describes these columns. As you can see, the temperature, rate, temp, humidity, wind speed, and count. So yeah, just shows you the mean and all the other metrics. Mean and median values of temperature is approximately 0.5. The mean and median value is approximately 0.47 and 0.48. Mean is approximately 6.7 and 9.63. And speed has some extreme values at the right end. Target variable seems to have a skew distribution of the higher values on the right as forward this further. So yeah, so target variable. So the reason that they did all of this is just to see what is going on with these values and to see if there are anything that we can capitalize on. For instance, in this case, the target variable seems to have skew distribution as higher value on the right. So since this is skewed to the right, that means that there are a lot of items that we can explore later on. So that gives us a little bit to focus on. Then the number of unique values in each column, and so yeah, they're all different and everything. So it's good. And here they're dropping the instant and the TE day, so they're not really needed. So it's dropping it as it just contains dates of 731 days. Example 2 years. This will not add value to the model. So this is where you define like exactly like, okay, is it really worth having it or is it not? And based on that, you decide whether it's a good column to train on or not. And obviously they dropped it, so they dropped it with this function and the number of observations in each category. And so again, they just run a for loop and check to see all the value counts and just compare or observe, what are the counts of those values. And the number of observations from year 0 or 2011 is slightly more than the number of observations from the year 2012. So number 0 in the data set refers to 2011. So this right here is what they're talking about. So the number of observations from year 2011 is slightly more than the number of observations from 2012. So here, we're comparing those two. As expected, the number of non-holidays and working are much higher than the number of holidays and non-working days expected. And again, they're defining those things and examining what is going on. Then they make a copy of the data set because they remove a bunch of values and you don't want to work with the original data set. It wouldn't be smart, just to start removing things and manipulating the data set that you cannot go back to. So yeah, so they make a copy of the data set and now they do the exploration analysis by the way of doing the histographs and all this graphics to represent the numbers. So they say the EDA section has been covered multiple times in the previous case studies and this case study. Like I said, this is just an exploration that I picked up and I kind of wanted to share this because this goes a little bit further down, like the modeling and how to get the best model utilizing um, some other methods. And so all of this is basically I've covered it, and I haven't presented it in a video or anything like that. So I apologize. If you want to learn more about this, let me know, and I can create another video about how we come all the way to this to where we are. This is a little bit more. It's advanced, but it's more like having a way to not repeat yourself. So this is creating a function, and then you later on they're gonna plot all these numbers like data set, which we already know what we're using, and we created a new data set name called df. And so then the feature size, or the figure size, I mean, that's how big the image is going to be, and all these other parameters that they do other things. But I'm not going to cover this. If you want to know more about that, let me know. I'll be sure to do another one. So these are just functions that are going to be plotting the different bar plots. And with that, they're using the histogram plot that I mentioned before. So it's this right here. They're using this function or method, whatever you're going to call it. And then they plug in the data, and they want to look into the read speed. And so this case study is based on AdaBoost and other ways to see how to fix or how to get the best problem, like how to get the best model out of it. So first they create a model, and then it's like, okay, how can we improve it? And the way you improve it is by utilizing ensemble technique, an ensemble technique, which is one of many techniques to get the best model out. So in this ensemble technique, we're going to be using bagging, boosting, and stacking to predict the count of bytes rendered. And what that is like we're going to focus on these outliers. Since there are many outliers, we want to analyze those. And this is the best way to see it. Okay, well, if the data was clean and they had not outliers like that, we could just focus on this. But since there are outliers, we want to see and explore what is the best thing that they have to provide. Again, look at many other ways to look at the data, and those are outliers to do with wind speed. I don't know why it would matter, but wind speed has an interesting set of outliers. Probably not that many, and we'll see what they do with it. So wind speed has a right skew distribution, and 0 has the highest count among all observations. The distribution is not symmetric, but mean and median are approximately equal to the value of 0.19. There are many outliers in this variable. Like I said, we're going to see what they're going to do with that. Then another column. Again, CNT, I don't know what that is, so let me see what they're looking into. It is the count of total rental bikes, including both casual and registered. So I'm expecting to see a lot of outliers. Yep, lots of outliers. So this is going to be crucial. This is going to be our target. We're going to define what is the business recommendation we can give, what is the best one, and we're going to create a model to predict the count of bikes around here. Again, data count and which one is the largest. So yeah, we can see that this is the largest, and largest value. So yeah. The target variable, the count of bikes rented, has a high skew distribution. The range of the values is very charge with many observations being less than 10 counts, and some being greater than 900 count. I said it for the box plot. That is for the box plot. So here. Now they're gonna utilize the bar plot as the other function, which is this one. So with this, we're gonna explore the weather sit, and weather sit is clear, mist, light snow, heavy rain. So yeah, this is what it looks like. I guess one is clear or with a few clouds, or partly clouded with cloudy, which is the highest percentage here. And 26 is mist or cloudy, or mist and broken clouds, or mist with a few clouds for mist. And then 8.2% is light snow, light rain, thunderstorm, or scattered showers, scattered clouds, light rain, and scattered clouds is what that is. And then number 4 is heavy rain, ice pellets, thunderstorms, mist, or snow and fog. So obviously nobody goes out and rents or does anything with that. So yeah, they just mentioned all of that. Tabletop. Again, the same thing, but on a working day. So the working day is if the number 1 is if day is neither weekend or holiday, then put a 1. Otherwise, you put a 0. So this is weekends or a holiday, and this is every day, every other day, or every day without those characters. And then the analysis, the 5 or 8 analysis is just the correlation. You know what is the most correlation there is. And so you use this figure, heat map, and see what makes more sense. So we're gonna do we can see that the temperature and the fuel light temperature are almost perfectly correlated. So let's look for temperature, and fuel light temperature is right here, are almost perfectly correlated. So as you can see, you know, pretty much have like really good values, but we don't know that. So anyways, let's keep on going. Month and season have a high positive correlation among them. Month and season, month, positive correlation. And as running additional 2 columns, casual and register. Casual and register. We can drop these 2 columns because if we had casual and register counts, then making a model won't make sense, as we can simply add them. We would not have these 2 columns while predicting the observations. So, alright, casual and register. Sweet. Now another way of plotting or seeing the data sets and everything is by using the cat plot, and it's just another way of seeing the data. Not even gonna worry about those. I mean, we already see that we have a lot of outliers and everything, so we already know. But you know, you want to visualize things so you can explain it over to your audience. You know, it might be another data analyst or another data scientist, or it might be the business owner. So you just want to make sure that you know how to read these graphs and just explain to them. You can pick out of, you know, like many different a variety of graphs and models. So like this one, it's like the candle model or candlestick. And so you see right here they're comparing the hour and the count of bicycles with a bar graph. And so at what hour are the bicycles rented the most? So it looks like at 8 o'clock, 8 in the morning, and let me see, 5 and 6-ish. We have another one comparing the month, or what is this? Yeah, the month, and the count of bikes. So it looks like probably like around summer and October, May through, what is it, October. And so again, you just start observing and everything, and now data processing. So this is where you look at the outliers and everything and how you're gonna treat them, and that's what we have here. It's like, okay, so what are the outliers that we want to look into, and where do they shift or anything like that. And so this is utilized to just plot the different columns and see which ones make sense. So they say that there are quite a few outliers in the data, however, we will not treat them as they are proper values. Actions for data processing. As count is the addition of 2 columns, cash on register. We can drop these 2 columns because if we have cash on register, count them. Yeah, we saw this earlier. So okay, they're just repeating it. We will not have these 2 columns while predicting the observations. Yeah, you told us already. Let's move on. So they're just dropping them from the data set, and they're continuing to creating a model or preparing the model. And so the model is on the X and Y axis, and basically it's a binary model. And so they split the data into train and test sets of the 70-30 ratio. And so they split them, and some of them are going to be trained models, and the other one are going to be test models. And the more test models, or the more data you have, the best trained models. So they're just combining them, or actually separating them, making 2 test models. And we have 12,165 observations in the train set, and 5,214 observations in the test set. And I believe when you combine these 2, it equals to the full amount of the data entries, or the data we have available to you. So now this is they're starting with the bagging model built in, because this is what we're focusing on. We're focusing on the bagging, boosting, and stacking models to predict the count of the bags rented. So they're will fit different models in the train data and observe their performance. We'll try to improve the performance by tuning some hyper parameters available for algorithm. We'll use grid search and hyperparameter tuning and R2 score to optimize the model. R-square coefficients of determination is used to value performance of every regression model. It is the amount of the variation in the output dependent attribute, which is predictable from the input independent variables. We'll start by creating the function to get the model score so that we don't have to use the same codes repeatedly. Yeah. Again, this is a little bit of an advanced machine learning, and if you are interested, let me know, and I can point you to some great resources that you can utilize to catch up or actually learn a little bit about machine learning. And so here is building the some functions or methods. I like to call them methods, but I find myself saying functions because I come from a background of utilizing functional computing models. So yeah, I don't know why I never liked to use class approach. I don't know, but anyhow, moving on. So yeah, functions to compute map or mappy, whatever you want to call it. That's another thing. Python and machine learning have a different way of pronouncing things. So yeah, I'm still learning about how to pronounce them. So bear with me. Model performance regression, so another function, and it just tells you, like what they're doing with it. And so basically they're just utilizing these functions to calculate different types of methods or different scores. Like this one, they're trying to score it. Yeah, this one is the function to compute different metrics to check performance in regression model. So yeah, so what they're gonna do is basically, since they already split the model or created a model based on the count of rented bikes, they are going to basically compare and score and just make the best model out of that one model. And so that's why they're doing all these calculations, because you don't want to write this all over every time you want to compare something. So these models are going to be used to test different models. Now they're building the decision tree model. So the first one was preparing the data that you're going to utilize. And now they're creating the data, the tree model. So they're doing a tree model first, decision tree, regressor. And so now they build the model based on the data set from on here. And now they are importing another library. So they're importing R2 score, mean square error, and mean absolute error from this library. And then they're going to form the model. They're going to train the model, and then they're going to train the training performance. Yeah, so E3 is the model, and so they're doing the model performance regression based on D3, which is right here, and then they're including the X-train and Y-train, which are these data train sets or sets of data. And so based on that, based on the training performance, it's really pretty good here, but the R square is looking a little bit that it could be overfitting. So yeah, see, like the decision tree model with the full parameters is overfitting. So yeah, so you don't want to get too close or really low. So it kind of like this one can attempt to overfit. And so yeah, so you want to do that, and then let's see if we can reduce the overfitting by improving performance of the first data by tuning hyperparameters. Hyperparameters are just parameters. I don't know why they use hyper. I don't know if they're gonna do, I don't know, wash their dishes or something for them. I don't know. But they're gonna utilize that parameter to predict better performance. So this one, it was on the train set, and this one was on the test set. Remember, we split the sets up here. Split them right there to 70-30, and that's why you have two different training sets. So now they're using the hyperparameter tuning, and so they built the hyperparameter tuning by using the grid parameters. And this one is a little bit of a complex way of not complex, but kind of like it was explained to me as because my question was, how do I know to choose these numbers? And there's a way to do it, but they utilize another method to get them out, and it's a little bit about you have to do that first to get it over here. But these are predefined items, and there's a computation function that you utilize to get these models or these numbers from the model. But anyways, they use that decision tree or the grid parameters, and then they score the metrics using these R2 score. And I'm just gonna read this because I'm just trying to explain everything, but I'm not. So the type of scoring used to compare parameters combinations, and then that's what it does. And then run the grid search. This grid search is just looks for the fitted models of X train and Y train. And so they're doing the X train and Y train sets, and so they're gonna do and build the decision tree regressor, which is another model. So each one of these things that you see in blue are models, and what they're doing is building models based on different parameters. Like this one, they're using the hyperparameter tuning. So let's see, parameters are these. Those are the hyperparameters, and then they create a model, and then they test the model to see how well it's performing. And so again, they share their observations, and they say the overfitting is reduced by the hyperparameter tuning, and the test score has increased by approximately 2%. RMSE is also reduced on the test data. The model is generalized better than the decision tree model with the full example. So it's a good tree, good model, but they're going to do more models just to see if that is the best. Plotting the features of importance of each variable. So now, since they got a model, now they're going to see what is the most important item here of the data set. So they list the data set and with the tune tree, and they want to see the feature, the importance of each feature, like how they categorize each feature. And so they look at it, and they look at it, and then they plot it. So obviously these are actually this is the most important thing, is hour of the day and the temperature. I think those are the well, you go with these three. I would probably go with the four, all four, because this is pretty good to see that the weekend is not really a good time to rent the bike. So that was good to see. We might or may not see this being utilized, but obviously the year, the temperature, and the hour of the day, that's what drives all these rentals. So now they're going to train another model using random forest, and so they're going to train it, and they're going to test it and see if it's a good fit or not. So random forest gives good R2 score. Square. 94% on the test data, but it's slightly overfitting the train data. So train data is overfit. I mean, the train data is overfit slightly. Because you don't want it to be like the closer to 1, it means that it's overfits. Let's try to reduce the overfitting by hyperparameter tuning. So now they're going to do another hyperparameter, and it's going to be the random forest regressor, and so let me see. Okay. Now we're gonna tune it with I'll put that on the tune. Because we're only training we're tuning the grid. So here we have 2, 3, 4, 5, 6, 10. Range from 2 to 20. Let's see what they use here. So they are not using range, so we're just giving the number and the end estimators. Wish there was a way to just go here. Yeah, so they're changing the values of these. Previously they used max depth in sample lead, max lead nodes, and period decrease. So here is a different set of parameters: max depth, max features, and estimators. And so they create the model, and they train the model. They test the model, and no significant change in the results, so the result is almost the same as before or after the hyperparameter tuning. So yeah, so that's like okay. And now they're gonna look at the data again and see if anything changed. Obviously nothing changed. So yeah, we know that is the most important one. And like we said, temperature and year are the other ones. So they're leaving out, they're not talking about the working day. So it's really not necessary. Now this is another one, auto boosting. And so they're gonna tune the hyperparameter. And so now by using auto boosting, it's like another way of adding the hyperparameter. So they built a model utilizing that. Now they're just going with the default values on this, and then the same state, and just fitting in the model, and now they just check the performance. This one says Add Boost is generalizing it, but it's giving poor performance in terms of R2 score as well as RMSE as compared to the decision tree random forest model. So yeah, that was not a good one. And then hyperparameter tuning. So now they're gonna train or tune the auto boost regressor, which is like what they were doing here with the default values, and now they're going to train it with a little bit of parameter tuning. Again, hyperparameter parameters. So now they build another model and they test it, and what we can see is that there's significant improvement. So this model is like okay. Continuing on, what gradient boosting. So another, they're gonna do the same They're gonna do default values with the same random state, and they're gonna do the testing of this model, and gradient boosting is realizing well and giving decent result, but not as good as random forest. Remember, random forest is the one we saw on, I think, the second one we saw. And now they're gonna train this with hyperparameter tuning, and they're gonna add these values, and we'll see what that does. So we're hoping to see better performance, but we don't know. They increase the ranges and everything, so they have a little bit more items in there. And so we're gonna see this right here. They're training it, and then they say we can see that the model has improved significantly in terms of R2 score and RMSE. The 2 score has increased by approximately 12%, which is significant. On the test data, RMSE has decreased by more than 30% for the test data. So what? We'll see. So now they realize the importance, and again, it's looking the same, nothing changed. Yeah, all of that. And now they're gonna do yet another model, and so they're gonna test this, and we're gonna see what it does. I hope you guys can hear me. I've been talking to you all, and I haven't seen if it was working or not, but I hope you guys can hear me. Otherwise, I'm gonna do a voiceover and I'll guide you through it. Alright, so they checked it, and the HG boost with a default parameter is giving almost no good result as the tune gradient boost model. Okay, so they're gonna tune it, they're gonna utilize the same method, and now they are creating the model, and they're gonna test it, and then they're gonna say they didn't actually check this, but it looks to be pretty good. It might be a little bit overfitting, but we'll see what happens. Alright, so now we can see some changes. Now we see that these three improved. This one still, actually this shifted because the working day. So remember, the working day is the one that I was like telling you, I don't know if we're gonna be using it because it only has like two big, two features, which is like weekdays and holidays or weekends. But now it shifted to be like the most important thing. So we'll see what they say. It says in Energy Boost, working day is the most important feature, followed by the features hour and year. Stacking model. Now we're gonna do yet another model, and now let's see built-in stack model with the tune models, decision tree, random forest, and gradient boost and HG boost. So what this is they're gonna actually do a test against the build models that were up here. All these training models that we saw earlier. So they're gonna stack them and then make a better prediction. And so they combine them and everything. Stacking is like, it actually shows you the stack progress. So they're gonna go decision tree, random forest, gradient boosting, and XGD regressor model to get the best out of all of them. So now we're gonna combine them, compare them, and then test them. And so, as you can see, R square can be a little bit, actually shows pretty good. These two show pretty good. And then the testing set shows about this. Shows good. This is a little bit overfitting, but we'll see what they say. And then they're gonna compare all the models. Alright, so here is the comparison of all that modeling that we did. And so we're gonna say like, which one is the best model to adapt, and based on the what they see here, or what we see here, is what we're gonna be using to predict the best outcome for getting the bike rentals and making a recommendation to the business. So when they're testing the comparison, basically they're going to test all the performances and everything, and they're going to give a total, what they see and everything. So it says the tune gradient boosting model is the best model here. So let's look at the tune gradient boost tune. So this right here is the best one. It has the highest RQ score. So the highest score, and then approximately 95.5%, and the lowest RMSE score, which is this compared to the rest. And then gradient boosting, HD boosting, and stabilizers are the top 3 models. They are giving similar performance. Alright. So at this point, I think that they can test. Okay, so yeah. So the plot looks around predicts the values of the test data for the best model. Tune gradient boosting model. So they use the tune model to make an observance utilizing this top grid. And so they see it. You can see that the points are dense on the line where predicted is equal to the observed. This implies that most of the predicted values are close to the true values, with some exceptions as seen on the plot. Then the recommendations they give is that we can use this predictive model for any recent environmental parameters which we know in advance. We can predict the count of the bikes to be rented, the ability to predict the number of hourly users can allow the entities that oversee the systems to manage more effectively and cost-effectively. Most bikes can be made available for the fall and winter season as the number of bikes rented is high on winter seasons. As the number of bikes rented are high for day timing compared to the high night timing, similarly fall and winter season have more surges compared to the seasons. We can choose differential prices of bikes accordingly. As most of the rentals are commuting to the workplaces and colleges daily, company can launch more stations near busy workplaces as school, colleges to reach out their main customers. Number of bikes rented is going to be independent of the weather, so we can shoot the number of available bikes in the area based on the weather forecast. Maintenance activities for bikes can be done at night due to the low usage of the bike during the nighttime. Company can provide offers or coupons like monthly subscriptions to compensate for the low count on holidays or weekends. And that is all. So as you can see, the data analysis and prediction model building, it is intricate, and it can be pretty extent to utilizing it and everything, but at the same time it is pretty cool to see how you can utilize machine learning to get the best value out of it. And this is just a little bit about the prediction models that I'm learning, and can't wait to see what I can now plug it into either work or outside from work. So yeah, thank you for joining. I'm gonna try to do more of these. These are just like review items, but next time we'll do a hands-on learning. This is advanced, so I'm probably 3 months into this, so it takes a little bit to learn how to plot and how to do all of this, but it is really nice to know about these models and how to utilize Python to create anything and everything. Again, if you would like to learn or know how to utilize Jupyter or Python, hit me up and we can learn together. Okay. Well, that is all I have. Again, my name is Javier Vilchis. I am a senior web developer and I do random reviews or analysis of anything that I'm either learning or interested or observing. So, yep, that is all I have. All right. Well, have a great day. Have a great weekend. And thank you for joining.